Chapter 2.8, exercises 13 through 20, and section 2.8 in the book has to do with solving polynomial inequalities. And in exercises 13 through 20, solve the polynomial inequality graphically. And this gives me an excuse to go straight to our calculator, but I'm going to, it looks like I can probably factor this out. And since I think I can, I'm going to try to do this. So we're going to write this function as f of x equals x cubed minus x squared minus 2x. And we know we're trying to look where this value of the function is greater than or equal to 0. And it looks like there's a common factor between these three terms of x. So factoring out an x, what times x equals x cubed? Well, that's going to be x squared. What times x is going to be negative x squared? Well, that's going to be minus x, or negative x. And finally, what times x equals minus 2x? Well, that's going to be negative 2. And we can factor this last section here, this quadratic trinomial. We have x and x, and we have either negative 1 times 2 or negative 2 times 1. And since we have a minus x, I reckon that it should be 20x minus 2 times 20x plus 1. If we multiply back together, we get negative 2x plus x. That's going to work. So we have zeros where x is equal to 0, and that's going to be multiplicity of 1. And then we're going to have, for this x minus 2, we're going to have x equals 2. That's also multiplicity of 1. And finally, x equals negative 1. That's for the factor of this x plus 1. X equals negative 1 with multiplicity of 1. And what this is going to look like, a cubic, it's going to look like the cubic parent function, basically, or at least have the same general shape in behavior. So things are going to start low from negative infinity, go up. Let's see if I can draw a little more accurately. Yeah, kind of go sideways here at the origin, and then goes up like this. So this is just a general shape of a cubic function. That's going to be f of x equals x to the third power. Now, what this is going to look like is, let me erase this here. With these zeros here, we have a 0 for this function at x equals negative 1, at x equals 0, and at x equals 2. So negative 1, 0, 2. So we're going to have a starting from below negative, from greater than negative infinity, going straight up. And since we have a multiplicity of 1, at x equals negative 1, we go straight through, and then we come back down through x equals 0, and we say straight through because x equals 0 has a multiplicity of 1 also. And then we go back down, and then come back up through our last 0 here, which is x equals 2. And that also has a multiplicity of 1. So, see, greater than or equal to 0, we're going to have greater than or equal to 0 in this interval between negative 1 and 0 and 2 to infinity. So we'll say greater. Okay. solutions. I'll say solution set. How's that? Solution set, we're looking for greater than or equal to 0, so we're going to go from 1 to 0. And why do we have brackets there? Well, the reason we have brackets is because, so that should be -1, 0. The reason we have brackets is because we're looking for where we are greater than or equal to 0. In union, we have from 2 to less than infinity. And in our calculator, we have this graph. We can go up and get this equation, press enter, and we see the same general shape, right? 0's at -1, 0, and 2. So that confirms our answer. And we're going to go on to our next, over here. We'll go ahead and box this in first. We'll go to our next author problem, which is 15. And here we have a cubic polynomial, which really we might be able to factor this out, but we've been given the out here to solve the polynomial inequality graphically. So I just take that as license that we'll go to our graphing calculator, and to do that, go here and we enter that function, and here's the function 2x cubed minus 5x squared minus x equals 6. Press enter. Okay, and we have zeros here. It looks like x equals -1, maybe about x equals 3/2 or something like that, and at x equals 2. So just going back to our problem here, if we have the function f of x equals 2x cubed minus 5x squared minus x plus 6, and we go back and look at the graph here, we have -1, so let's go ahead and write this out. For the graph, we have just what our graph looks like. We have a 0 at -1. We have another one here at 2. And this one over here, I'm not quite sure what it is yet, but the function is a degree of 3, so the graph of the function goes up through 1, comes up here, touches the x-axis somewhere here at less than 2, and touches the x-axis just like at 2, continues up like this. So we really are interested in greater than 0. So the key thing are going to be these points right. It looks like we have -1. So solution set, we have, and we're looking at greater than, so we're going to say greater than -1 up to, we got to find this next 0 over here to the right. Go back to the calculator. We go to menu, analyze graph, 0, and here we go to the left, that 0, and to the right. Looks like we have a 0 of 1.5. So that's 1 0. That's going to go to -1 to 1.5. Oops. Or we call it 3/2. union. It looks like we're going from 2, to be sure here. Menu, analyze graph, 0. We're going to go from here. So we have another 0 at x equals 2. Go back in here, and we say 2 greater than 2 less than infinity. So we've really verified this as we've gone, that this is indeed our solution set. And on the little sketch I drew over here, where that question mark is, we'll put 3 over 2. Okay. The next problem we'll look at, starting with problem 17. We're going to graph the equation, and we have 3x cubed minus 2x squared minus x plus 6. So we're going to graph the equation, function f of x equals 3x cubed minus 2x squared minus x plus 6. And wherever this is greater, this value function is greater than or equal to 0, we have a solution set. We go Control I, we go to Add Graph, and we're going to go up and get this equation here, this function. It looks like we have just 1 0 here, and we're going to find out, looks like we're negative all the way up to this 1 0 around x equals -1, and then positive from there. So I'm going to go to menu right now, menu, analyze graph, 0. We're going to go to the left, to the right, we get a 0 of negative 1.15. So we go back here, and so we have a 0, x equals negative 1.15, and we're interested where the function is greater. So the function only crosses once, greater than or equal to. So solution set x, I'll just put this in interval notation, set, we have right here negative 1.15 comma infinity, and that's verified entirely by what we have here in the graph. It's just this one right here. So we have the critical number of negative 1.15. The function goes up. Negative infinity kind of bobbles here, but does not go down again to touch or cross the x-axis. So that's going to be what it looks like. So our solution set is over here to the right of this x-intercept. Okay. And now problem 19. We have function negative x cubed minus 3x squared minus 9x plus 4 is, oops, that's the wrong one, I want 19. 2x to the 4th minus 3x squared minus 6x squared plus 5x plus 6 is less than 0. So we're going to look at the function f of x equals 2x to the 4th minus 3x cubed minus 6x squared plus 5x plus 6. And wherever this value of this function is less than 0, that's going to be our solution set. We'll go to our calculator and y graph, and we go up here. This is the function right here. Press enter, and we have, we're interested where the value is less than. So the value of less than is going to occur right here between, like, looks like 3/2 and 2. What I'm going to do is kind of zoom in on that. So I'm going to go to Menu, Window, Zoom, and I wonder if they're going to let me do a box. Well, I won't even try it. I'm going to and say I'm going to go X-min from 0 to 3, and Y, I'm going to go for a Y minimum, let's say -3, and a Y maximum of maybe 3. See what that gives us. So it really gives us kind of a closer zoomed in look. So it's a matter of finding what these roots are. We're interested in this little piece here below the x-axis. So if we go to Menu, Analyze Graph, 0, we go to the left and to the right, we get a 0 of 1.5 or 3/2. We're going to analyze this again for the other root on the right, other 0. So go to Menu, Analyze Graph, enter for 0. We go to the left, to the right, so we get 2. So between 1.5 and 2, that'd be the solution set. So we say solution set we're looking at less than, so we're looking at interval notation, the parentheses. So we have 3/2, comma, 2. And we have parentheses because of this less than. And when we graphed this function, we saw the function touch down somewhere here to the left, kind of bounced back up, came around, and right here between 3/2 and 2, the thing went below the x-axis. So that's what it looks like. I hope this has been helpful to you. Good luck on following up on the even number problems, and thanks for viewing.